So here we have a little box, a little container with one little particle in it. Now it's a gas, so that particle is moving around. It's moving around, it's bouncing off the container. So this particle is bouncing off inside of this container, and it's sitting in there and it has a certain pressure. If you want to increase that pressure, it relies on two things. Because pressure, what's the formula for pressure again? Force over area. Pressure equals force over area. Now in this one, the area is the surface area of the inside of the container. So the pressure of that gas inside the container is to do with how much force is the particles hitting the inside of the container with, and what area, surface area. So instead of writing force over area, we could write down force of collisions of particles and container. So it's the force of these particles as they hit the container. More impacts means more force. This A is the surface area of the inside of the container. So the pressure of the gas depends on the force of the collisions, how many collisions, and the surface area inside. So to increase the pressure, we want to make the particles hit the outside of the container more often. You do that by increasing their speed or reducing the size of the container. So increase their speed, you can give them energy to increase their speed. To make them hit the container more often, we decrease the volume. So to increase the pressure, we do two things. We do one, would be increase particle velocity. Now to get increased particle velocity, we increase kinetic energy. Another thing we could do is to decrease the surface area, which is the same as decreasing volume. So, two things. I want to increase the EK or I want to decrease the volume. The last thing is, so how do I increase this EK? Increase my kinetic energy. Adam, what do I do?
Increase velocity.
So, but how would I add energy to this system then? Increases kinetic energy. How am I going to add more energy into this system?
Increases velocity.
Okay, but that's the outcome I want. I want to increase its velocity. I want to add the heat. That's where the energy comes from. So increases EK by adding heat. We're going to add heat. Add heat to do that. That means we're going to increase temperature. So, to increase the pressure, we can increase the temperature, or we can decrease the volume. Now, this is a step. It's like a step-by-step process for how we're going to increase this pressure. Are we changing the volume, or are we changing the kinetic energy that the particles have? And it's all about making sure they collide with the inside of the container as much as possible. The more force that they apply to the inside of the container, the fixed surface area increases the pressure. Okay. So, I'm not going to go into it in too much detail, but it's to do with pressure, temperature, and volume. So, to get pressure to go up, we have to lower the volume. So what we say here is pressure is inversely proportional to 1 over volume, or inversely proportional to volume. So if we want pressure to go up, we want the volume to come down. So it looks like that. Also, pressure is directly proportional to temperature. As pressure goes up, or temperature goes up, or as temperature goes up, pressure goes up. So we can also say now that PV over T equals a constant, and that also reads as P1 T1 over T1, P1 V1 over T1 equals P2 V2 over T2. That is a general gas equation. That means that you can calculate the pressure before, the pressure after, if you have either temperature or volume before and after. Every question you do in terms of pressure and volume will say to you, right, temperature is kept constant, or pressure is kept constant, or volume is kept constant, which means the volume or pressure or temperature before and after has to be kept the same. Now, they'll always tell you that in the question, so it's important you have to read the question thoroughly before you do it. But that is the general gas equation that allows you to work out everything in terms of pressure, volume and temperature. Take a data book. In your data book, the formula you get covers all this. Is going to be PV over T equals a constant. So this is the formula you get. You don't get the second one here. This is the one you get in the exam. Right? We're going to copy this down and then we'll do some questions on